Hey everyone. So I'm making this short video, hopefully short, to go over a couple notes for today on your carbon cycle food web diagram. As you can see, I have a basic one kind of laid out here on my whiteboard. I'll talk about that in 1 minute. You want to, of course, be looking at Google Images of some carbon cycles to guide your work. Just a reminder that on our energy and matter in ecosystems doc down here, we have our guidelines and requirements. So do make sure you're going through that list. I'm going to talk a little bit about adding some quantitative numbers, redundant, to your picture, and also labeling sinks and fluxes. But do look through this checklist, which again is on the energy and matter and ecosystems diagram assignment, which I put up yesterday. So remember, I did talk about the importance and the meat yesterday of having color-coded arrows for energy. So let's say that my energy, I don't have a third level consumer here because I ran out of space, but you should probably design yours so you have enough room for a third level consumer. So we've got, energy arrows, and then we're also going to need to have carbon flow as well. So energy and carbon need to both be labeled. And remember, a lot of these are going to be double arrows like this because we have both occurring. We're going to have energy lost as heat to the environment. That would be something I would label. We're also going to have carbon to the environment as respiration occurs, right? Remember that these animals here will be releasing CO2 back to the atmosphere as they perform cell respiration. And you should have respiration labeled there because respiration is an important part. Again, if you see it on a carbon cycle diagram in a Google image, try to incorporate it into yours. There's also, of course, going to be energy going to the decomposer level from all levels of the food chain. There's going to be carbon transfer occurring to that at all levels of the food chain. So I'm going to write in decomposers here. Now remember, and this is an important point, decomposers, this decaying organic matter, right? What I'm calling death and decay, that is not going to feed down into fossil fuels, right? We learned, and this is a crucially important point, that fossil fuels are deposited, like all fossils would be, only when decay does not happen. So I could have a separate pathway, which, again, should be, I'm kind of, let me change this because really this should be from mostly the producer level, right? Mostly from the producer level. This would be my death and no decay. Ending up as fossil fuels. Are there some animal remains in fossil fuels? We discussed this. Yes, perhaps. But the vast majority of fossil fuels, coal, oil, and gas, are plant matter. It's ancient forests, especially those swampy forests of times long ago, millions of years ago, because remember, these organisms need to be quickly buried or covered in some sort of layer that blocks oxygen from being present. Because if there's oxygen present, then bacteria of decay, fungi, decomposers, they'll take over and they'll break down any organic matter. So in order to form fossils, or in this case fossil fuels, like coal and oil deposits or natural gas deposits, we really do need there to be no decay, no decomposition. And that really takes very special conditions where oxygen is not present. Right now, I'm not going to draw this whole thing out for you. There's a lot more work to do here. I just wanted to give you a sense of what this is going to look like. Now, I am going to show you a little bit if I were to do this more with text boxes like this and no pictures. But let me first say, before I erase this, let me first talk about sinks and fluxes. A carbon sink is a place where carbon is stored for a long, long time, right? Look at a quantitative carbon cycle diagram, meaning one that has numbers on it, and you should see, like this is a good one, right? You can see how much biomass in gigatons, usually is the unit, are in these different places, and some of these will actually label sinks and fluxes. So right? Like this one says storage and fluxes. So let me just explain what that means. The ocean is a sink, right? Rock layers of the earth would be a sink. Fossil fuels would be a sink. Forests are a sink, right? Carbon sinks are where carbon is stored for a long time. It's not moving fast in its cycle. Fluxes are the opposite. Fluxes are where carbon is being transferred. And in a diagram like this, you can see those arrows showing those fluxes, right? So I want you to also add, maybe as a key or maybe as a label. You could of course, you could do, sinks like this, and you could have ocean written in your sink color. You could have fossil fuels written in your sink color. And I probably want to write carbon sink, right? Or you could label it in some other way, and then you could have the this brown line then could be the carbon flux, right? And I'll write in carbon flux in there. Okay, so that's I do, and again, I'm not giving you all the answers to what's what, but if you look at a good carbon cycle diagram, I think you're gonna, and I would look at more than one. Look at a few of them to start to get a good sense of where this carbon is in flux, moving between organisms and the environment and organisms, and also where there are carbon sinks. Now, real quick, just to finish this up, I just want to show that you could, your drawing can be whatever makes sense for how you want to show the information. I'm not really exactly sure what I'm about to do here, but you could show all of these labels simply as text boxes if you wanted to, right? So you could show that, that food web, whoops, my black marker's running out. You could show a food web like this. You could do the food web vertically if you want. There's no rule about whether you need to be vertical or horizontal, but I would distinguish between like soil and fossil fuels and the Earth's mantle or rock layers, right? Those would be things that would be, on one side of the paper, and then atmosphere would be on the other. So again, I'm doing this real quick and sloppy, of course, but I'm just showing you that if you did want your, ocean, if you did want all of this to be more flow chart style, that's fine. Okay, I think that's all we needed to go over today. I just want to stress the importance of that very short formation of fossil fuels video. Because one thing we're going to be looking at is what happens, and I think a lot of you know this answer, what happens when human beings take carbon out of a sink and move it to the atmosphere, sort of put it in flux in this system. We're not changing the overall level of carbon in the system. We're changing the location where the carbon is. And I think you guys know that atmospheric carbon dioxide is a greenhouse gas that can warm our planet. And the narrator, who kind of speaks in a funny voice like this in that video, some form coal and others form natural gas. That's kind of my impression of that guy. But he makes it a very simple and important point about this at the end. That video is so short and so important that I would, as I said on the assignment, I would suggest you watch it at least twice. Okay, and so by Monday, I'd like a rough draft, like a finished rough draft of your entire poster with all the checklist items on it. And when I say poster, I mean like a white paper or digital. And I would like you to finish the doc that I put up yesterday. And that's it.